Hello all, very good morning. Thanks for joining the session. Let me share my screen. Hope you all able to see my screen, I believe. Today, as part of the continuation to the yesterday's demo, today, let us see what are microservices and how we can deploy these microservices, the Kubernetes cluster, in the Kubernetes cluster. First of all, what is the microservices ecosystem and what are the components that were there in the microservices ecosystem? So all those things, let us try to understand. Of course, if any Java guys were there or my Java real-time project batches or my Spring Boot microservices batches guys were there, they might already know this. What are microservices, what its architecture and all, but for the DevOps guys also, it should be mandatory to know the microservices architecture. So that's the reason I'm again explaining this microservices architecture now, and then we will see the how we can deploy these microservices into the Kubernetes cluster. First of all, we need to understand what are these microservices. In order to understand, first we need to understand the monolithic application. Monolith or monolithic application we need to understand. So for that, I'm just opening one source code just to make you to understand. Here, microservices are not belonging to only Java or not belongs to .NET, not belongs to Python. They are not language specific. Microservices are, it's a architectural design considerations or architectural design pattern, first of all. Okay, if you can see here, just a moment, let me open the Shopify platform workspace. Just give me a moment, I'm just opening the application. So first of all, what is monolithic architecture? Monolithic architecture allows the development of different components such as application logic, business logic, and data access logic. All are bundled in a single archive. So in simple, monolithic application meaning a project may have the many modules like this. One moment, let me open the another workspace as well. Quickly, let me open another workspace quickly. Shopify platform, brownfield MS, yeah. Okay, now if you can see this, there is a Shopify platform backend application. You can see this. In this Shopify platform backend application, first of all, this Shopify platform backend application is bundling as a jar file. So you can see here, this is generating a jar file. Okay, now if we can go inside it, it contains the various modules: brands module, category module, customer module, order module, product module, report module, and then other modules. At least all these modules were there inside the single project, and all these modules are bundling as part of the packaging of this application. That means when we build this application, we are getting the jar file. In that jar file, the brand, category, customer, order, product, all settings, all these modules were there. So let me try to draw it. Just let me open. Let me open our diagram, and let me just draw this. Give me a moment. Give a moment. Let me draw the diagram now. So what I'm saying is now, this is the jar file or var file. Okay. So this is the jar file or var file. Let's say jar file or var file or .exe file or whatever it is. So this jar file contains inside in it various modules. Let's say this is the brands module, and this is the category module, and this is the brands module, category module, and this is the product module, right? So brands module, category module, product module, customer module, order module. So this is the customer module, and this is the order module, etc. So all the function here, module meaning you consider as one functionality, order meaning one functionality. Let's say product is one functionality, and order is one functionality, customer is one functionality, and let's say brand, category, product, customer, orders is one functionality. So all these modules now bundled inside a single archive. Okay, and connecting to the database. Connecting to a database. Let's say this is the database. All these modules are connecting to this database. So I just have used a common arrow rather than using, of course, what I mean to say is brands is connecting to the same DB, categories is connecting to the same DB, and customers is connecting to the same DB. Customer is connecting to the same DB, and orders is also connecting to the same DB. Right? So this is called as now monolithic or monolith application. So what is monolith application? If all the modules of the application were bundled inside a single archive, then that architecture is said to be the monolithic architecture. So what is that? Monolith or monolithic architecture. Monolith or monolithic architecture. What does it mean? If all the modules of the application, all the modules of the application were bundled inside a single archive, then we can say that architecture, as a monolith or monolithic architecture. Monolith or monolithic architecture. Right? So this is called as the monolith or monolithic architecture. Okay. So what are the drawbacks of this monolith or monolithic architecture? Why we are going for the microservices architecture? So the drawback is, okay, before looking at the drawback, let's say this is either jar file or var file, we said, right? So this jar file or var file, how it will be deployed? How it will be deployed? Using the CI/CD pipeline. So it is regular, meaning the regular deployment only. That means regular deployment meaning this jar file, right? This jar file will be deployed, or var file will be deployed in our pipeline, through our pipeline. This code will push to the Git repository, because this is the complete project which contains all the modules inside in it. So this complete project code will be pushed to the source code repository. That means this entire project will be there in the source code repository. Let's say this is the source code repository. So this project will be pushed to source code repository. Entire project, I mean to say, if you can see this complete project, meaning all the modules inside the jar file or var file or archive. So all these modules code will be pushed to this GitHub or source code management repository. And from this, what will happen when the source code will be pushed to the source code repository, right? We will configure a hook here on the source code repository, and that hook will trigger a notification to the Jenkins saying that, hey Jenkins, there will be a hook. So that hook will notify to the Jenkins, hey Jenkins, here is the source code. So please pull it. Once this hook informed this Jenkins, then Jenkins will go to the Git repository, of course, a specific branch of the Git repository, and then takes the code to here. So let's say now this is the source code. This is the source code. That means the Jenkins will have the one build job. Jenkins will have one build job. So that build job, let's say this is one build job. This is one build job. So the Jenkins will have the build job. This build job will build this source code. So that means the build job will pull the source code onto the Jenkins, and then this build job will use as the Maven or whatever it is, Maven or whatever the packaging tool our source code is having. So that packaging tool it will use, let's say for a while, let's assume this is the Maven. For a while, just assume we are using the Maven. This is a Maven build project. So what it will do, this Jenkins will be installed with the Maven and Java and all. So this build job will now build the source code. So when the source code, first of all, it will pull the source code to the Jenkins machine. It will pull the source code onto the Jenkins machine, right? Again, I am talking about the monolithic application. Monolithic application meaning the application which contains all the modules inside in it, right? So that application I'm talking about. So it will prepare a jar file or a var file. So we can say artifact or one archive. So it will prepare one archive. That archive may be a jar file, maybe a var file, maybe a .exe file, right? Anything. So one var file will be prepared here. And this var file, I'm going to say this is archive. So this is the archive. Archive will be prepared. And this archive will be here. Please note down, we have one build job. So this build job is taking care about deploying this monolithic application, which contains all the modules inside in it, like brand, category, customer, order, product, report, settings, shipping, user, all these modules inside the single application. And that application is bundling as a jar or var. So I can say this as vShopify platform, vShopify platform application. So vShopify platform. And this vShopify platform is bundling as a jar file or var file. So it is bundling as a jar file or var file. So let me take that. So here it is the bundling as a jar file or var file. Single jar file or var file, I mean to say. Okay, so now this Jenkins have one job. So that job will pull the source code, and then this Jenkins will have one job. I mean to say one job, meaning one pipeline also you can say. Only one pipeline. Please understand that. Only one pipeline. So it have only one pipeline. So this is that pipeline. So that pipeline will pull the code from the source code repository, and that pipeline will build the source code and generate the archive. Once the archive is generated, this archive is proper archive or not. So that will be scanned by the scanners. That means the archive generated is properly with the coding standards or not, regular flow, coding standards or not. So that will be verified by the scanners. So let's say here, static code analysis. We call it as SAT, static code analysis. Static application testing also. We can say it as static application testing or static code analysis, SCA or SAT. So here what we will use the Sonar Cube. Here we will use the Sonar Cube for the static code analysis, or we can say it as static application testing. We call it as the SAT. So this Sonar Cube will have the quality gates. The Sonar Cube will have the quality gate. So this quality gate will gives us whether the build is qualitative or not. So this have the quality gate. So this quality gate will verify this build is proper or not, meaning whatever the build it is generated on that source code. The static code analysis will perform the analyzing, and then it will prepare one report saying that these are all the vulnerabilities are there. These are all the code violations are there. These are all the coding standards not following. So such a report it will generate, and based on the report, the Jenkins will take the decision to promote this archive to the next environment or not. So let's say quality gate is passed, then it will promote this to the Artifactory. So let's say we'll have a Artifactory. Of course, these are all the things you may know, DevOps guys may know. So, but let me explain one more time so that when the microservices deployment will come, you will feel the difference. So here it will be the Artifactory. Let's say this Artifactory may be the JFrog or maybe the Nexus whatever it is. So let's say this is the artifactory. So to this artifactory, now whatever this build is generated, right? This archive will be now transported from here to here. This archive is now transported from here to here. Once the build is proper, once the build is proper, this quality gate is success, then this archive will be transported to this artifactory. Why? What is the benefit? Because this artifactory maintaining the versioning, artifactory maintaining the versioning, it will maintain the versions. So let's say versions. The benefit of this versioning is what? We can go back and then we can traverse backward and then we can traverse forward as well with the deployment files. Let's say this artifact is here. This artifact, I want to get the, let's say yesterday's artifact or 10 days back artifact, or I want to deploy the version 3 artifact, version 5 artifact. So likewise, we can have a history of, not history, we can have a versioning of all the artifacts generated, and these artifacts we can deploy at any moment of time. So we can go forth or come back with the artifacts whenever we will maintain this versioning. This is possible. So the benefit is what? If the current version is having the problems, right? We can immediately deploy its previous version, or maybe it's a previous stable version of the artifact we can deploy so that the customers won't face any issues, right? Okay, artifactory, it will push to artifactory. Now usually our code contains the files. Our code contains the files. Let's say Docker file, and let's say other files, maybe Kubernetes files. Our code contains all these things. Let's say our code contains the Docker files or Kubernetes files. We'll have all the files here, right? Because all the source code from the source code repository will be pushed. All the source code from the source code repository, all the source code from the source code repository will be pulled onto this Jenkins machine, so that it will contains all the source code related components. So that source code contains the files like Docker file, Ansible file, etc. So what we will do here, we will use the Ansible here. So here we will use the Ansible configuration management server. Ansible we are using for the configuration management. So this Ansible Jenkins will give these files to this Ansible. Now Ansible will have the inventory. Ansible will have the inventory of the host machines to what it can connect to. So that means it contains all the target machines to what it need to connect to. Let's say this is container. So it will have the, sorry, 1 minute. So it will have this inventory. So we can say it as a inventory. This is inventory. And this inventory contains the details of the machines to which we can connect to. Let's say I want to connect to a machine. So this is one machine I want to connect to. Or let's say this is the Windows machine we want to connect to. Or let's say there is a Mac, there is a Mac machine that we need to connect to. Whatever it is, I mean to say here, all the target missions configurations will be inside this Ansible inventory. So this is called as what? Inventory, Ansible inventory. So this Ansible inventory having the target missions configuration. So this Ansible already having the target missions configuration. So what it will do is it will connect to the target missions. Let's say this is what the Docker mission. Let's say this is what the Docker mission. This is what the Docker mission. So what it will do? It will transfer the files. It will connect to this Docker mission, transfer the files, Docker files and all to here. Here Docker installed, of course, on this machine. Docker we will install. So this Ansible will do what? Ansible will execute the pipeline. Ansible will execute the playbook here. So it will have the command line. So from the command line, when it will execute the playbook, so here in this playbook, here in this Ansible server, when it will execute a playbook, this will connect to the inventory, meaning the inventory details it will load and then connect to the target machine. And then the playbook contains a set of tasks. So those tasks will be copy the files from here to here. And also those tasks will execute the Docker image building. So when it execute the Docker image building, now this Docker will go to the Artifactory. Docker will go to Artifactory, and then whatever the artifact that so it will go to the Artifactory. So this is the Artifactory. So whatever the artifact here, that artifact it will downloads onto the Docker machine. Now, using the Docker file and using this artifact, using the Docker file and using the artifact, it will generate the Docker image. So let's say this is the Docker image. So this is the Docker image. So it will generate the Docker image. Remember, this is for what? For one application only. That is this monolithic application, right? Which contains all the modules inside in it. That monolithic application is now we are deploying. So let's say Docker now build the Docker image with this artifact downloaded from the Artifactory and also the Docker file that has been copied by the Ansible from the Ansible machine to this Docker server. Once this Docker image will be prepared, it will be pushed to the Docker hub. It will be pushed to the Docker hub. Let's say this has one more container. So it will be pushed to the Docker hub. So let's say this is the Docker hub or private Docker registry. Private Docker registry. So to this registry, the artifact will be whatever the image, that image will be pushed to this Artifactory. So here, whatever the image is there, that image will be pushed here. One moment. So whatever the image we build, that image is pushed to the private Docker registry. So we can say now continuous integration is completed. Then immediately what will happen? Immediately what will happen is one more build job we will prepare here. One more build job will prepare here. That one more build job will do what? Again, one more build job will execute here. This is another build job. Same pipeline, but one more build job. So this build job will trigger this one more build job. So whatever the source code and all we have, That source code is here. Whatever the configuration files are there, those are here. And one build job will be triggered. This is that build job. And this build job will do what? It will deploy the Kubernetes YAML files. So as yesterday I have shown you somewhere, the Kubernetes YAML files. It will, let me go back. Let me showcase you that Kubernetes Docker files, Kubernetes files. Let's say not here. Let me, create nodes. We Shopify. Yes. So these are all the Kubernetes files, deployment files. So these Kubernetes deployment files now, pulled onto this Jenkins mission. This Kubernetes deployment file now pulled onto this Jenkins mission. And these Kubernetes deployment files are nothing but these files. So these are all Docker file playbook and all. This is Kubernetes files. Now these Kubernetes files also copied to where? These Kubernetes files also will be sent to Ansible machine. Also sent to Ansible machine. Now Ansible machine will have the Kubernetes files also. Let's say here are the Kubernetes deployment files. Now what Ansible will do? Now Ansible will deploy, meaning Ansible will run these Kubernetes files on the Kubernetes master machine. So these files will be copied to Kubernetes master and it will run a playbook, and that playbook will deploy the files onto Kubernetes master. As soon as these Kubernetes files will be deployed here, you can see now we mentioned in this Kubernetes files the image. What is the image that we need to pull? So we mentioned the image details. So as this image definitely will not be on the Kubernetes master machine. So what it will do, this Kubernetes master machine will go to Docker registry. Of course, the registry, whatever the registry we will mention here, it will go to that registry and fetches this image file onto this master machine, Kubernetes master machine. Now this image will be deployed. Now this image will be deployed as a application. So that means it will run the pod. This is called as a pod, and this pod contains the container inside it. Of course, we'll discuss about this pod, container, everything. So this is the pod, and pod contains the application. So finally, here we can see the application. So whatever the application will have, meaning whatever the application, Shopify application we build, that application we can see here, right? So this is what the, here it is. Sorry, one moment. Control Y. So here it is. So this is what the complete pod. Yes, this is what. Now from the image it downloaded. This image it ran in as a container inside this pod, so that the application will be deployed and then run. And this application now accessed by the users. So who are the users? Application users. These application users will now access the application inside this Kubernetes. Hope all of you got it. Now, from this application, the logs and all will be generated, right? So we will have the complete ELK, whatever the logs, those are generating from the application. So for those logs to see and then manage, we'll have the ELK system here. This is the ELK system, which will pull the logs from this pod. And similarly, there is a monitoring system. Logging and monitoring are called as the observability. So there is a monitoring system. This is the logging system. We can say as ELK, and this is observability system. We can call it as Grafana and Prometheus, or we can say it as simply Grafana. So let's go here and then get the ELK logo. ELK, ELK, sorry, Elasticsearch ELK. So this is what the ELK, yeah, so okay, so Kibana Elasticsearch. So this is what the process it will. This is what the process it will do. So just let me take this screenshot and then put it here. Just let me minimize, and then this is our logging system. Yes, here is our logging system. And similarly, here we have the Grafana and then Prometheus for the monitoring. Grafana and Prometheus we have for the monitoring. So let's say this is what the Grafana. This Grafana will use the Prometheus as a database. So let's keep this Grafana here. Okay, so now this is what the complete CI/CD pipeline for one application. For one application. This is for only one application. Similarly, when we go to microservices, how this architecture is, let us see. Okay, so how this architecture, when we go to microservices, let us see. So now you might got the meaning of this monolithic architecture, I believe. So you might got the meaning of this monolithic architecture, I believe. All the modules inside a single archive or single bundle. Such application is called as the monolith or monolithic application. So what are the drawbacks with this monolith or monolithic application? What are the drawbacks of it? The first drawback is single point of failure. Single point of failure. Guys, can you please mute yourself? Single point of failure. What is this single point of failure now? Let us see. This is the first problem. What is the single point of failure? Let's say there is a products table here, right? All the tables definitely will be created inside the single database. So now we have the product table assume here. Let's say that product table got corrupted. So this product table got corrupted due to the heavy data or due to some other reason. The product table is corrupted, or this product table got some issues. Then the database thrown one issue. Let's say duplicate product is trying to insert in here, or not duplicate. Let's say any other, for example, Guys, can you please mute? I will give you the time to unmute yourselves. Right now, I am I removed the unmute option. You can't unmute. Raise your hand whenever you will get some doubts. I will allow you to unmute. Okay. Single point of failure meaning what? Assume the database size is now some, for example, 1 GB, 2 GB, whatever it is. Let's say due to the continuous product upgradation or product installation, let's say this database size got filled, or any database related issues we got. As a result, what will happen? We not able to access the entire application. This entire application we won't access because the error thrown by this database, fatal error thrown by this database. Now understand the problem with what? Problem with the product table. But though the problem with only the product table or product module, the other modules also now not accessible. The other modules also were now gone. The entire application was gone. We are not able to access the application due to this error. Unless we resolve this error, application don't come back. So that means what? Due to only one product module, the other modules are, even though other modules are doing good, they don't have any issues. But due to the product module issue, the other modules also got failed or not able to respond or not able to serve the requests. So this is called as the single point of failures. The single point of failures, the occurrence of the single point of failures were more in this monolithic application. This is the first problem that we can say. And what is the other problem? Other problem is performance, or else let's say bundling. Let's say bundling. Let's say we are now updated or we are updating the customer module. We have written some code changes here in the customer module. I didn't touch this product module, category module, brand module, orders module. We didn't touch this. They are doing good. They deployed well. They are doing good. I just only changed this customer module. But though only the customer module got changed, we have to again build this entire application. We have to build this entire application, which is not correct, but we have to do, because all the modules are bundled inside a single archive. So the bundling again we need to do. This is the another problem. And the most problem is what? Performance. Performance. How the performance will be the problem? Let's say these usually orders and then the products are most affected modules, meaning mostly used modules. These orders and then products are mostly used modules. Let's say when we open the Amazon, what we'll do? We'll search for the products, right? We'll search for the products. We'll search for the offers. And once the products will be searched and then we finalized, then we will place the orders. So orders and then the products are mostly searched or most commonly used module, so that they will face the heavy traffic. So products and then the orders are facing the heavy traffic. That means retrievals, insertions, updates into the DB, right? These operations will be happened for the product and then orders. Keep on these operations will be happened. Due to the logs, because it's a single database, right? So the single database, due to the transactional logs, what will happen is the other modules, when they try to get the data, at the same time, the orders and then products are heavily served. The other modules will get some performance degradation. That means customers are placing orders, products, keep on they are doing. in the another machine, when I log in and then trying to see the brands, I may see performance degradation there because the database is busy. Database is busy in serving the product and then orders continuously. Of course, the logs will be applied on the tables only, not database. Logs will be applied on the tables, not database. Though the logs will be applied on the tables, not database, the database will give the data to this application via data source. That means network. That means network. This database will be in some other network. This application will be in your local machine. So over the network only, this will give the data to this application. That network, when busy, then the serving the data to the application will get little degraded. The performance we will see. The performance next we will see in these monolithic applications. So out of all these, single point of failure is a serious issue. That means if any one of the module will be failed, the other modules are also failing. This is a serious issue. Of course, the others are also considerable issues, but single point of failure is the major issue. So that's the reason to avoid these problems, right? The microservices architecture came into the picture. Of course, before microservices architecture, service-oriented architecture came into the picture, but I don't want to discuss about the service-oriented architectures. Again, let's go to directly the microservices architecture. So this is the monolithic architecture. Now, this monolithic architecture now converted to the microservices architecture like this. So this is the monolithic architecture. Now this monolithic architecture converted to microservices architecture. So let's say this is brands, right? So here is the brands, and here is the category, and here is the products, and here is the customer, and here is the orders, right? And customers will be bundled, or this orders will be bundled as one archive. This will be bundled as one archive, and similarly customers will bundle as one archive, product will bundle as one archive, category will bundle as one archive, and then brands will bundle as one archive. So what did you understand now? This huge monolithic, right, is now converted into the microservices. What are this meaning? Meaning all the modules are now converted into independently executable and self-deployable applications. Earlier, these modules are not self-deployable. These modules are not independently executables. Rather, earlier, these modules are bundled inside a single archive. This single archive is the deployable one. That means entire application is the deployable one. Entire application is the executable one. But these modules are not executables. These modules are not deployables. But now what happened? These modules become now independently deployable and self-executable. Independently deployable and self-executables. That means this brand may connect to its own DB, and then this category may connect to its own DB. So let's say database. So this will have its own database. Let's say the same database, let's take. So now this brands will have its own database, and similarly, the category will have now its own database. Category will have now its own database. Product will have now its own database, and then customers also will have now its own database, and then Orders also will have now its own database. So as a result, what will happen? So now let's say every microservice have its own database. This is called as database per service pattern. Database per service. Per service, one database. So this is to solve the so many problems that we have seen in the monolithic architecture. The first problem is single point of failures will be completely avoided here. So this is, and this is one of the, right? So every application, every module is now acting as a one tiny application, and every module of the monolithic application is now acting as one small and then tiny application, which can be built independently and which can be deployable independently, which will have its own database. As a result, what will happen? It will solve the problem of single point of failures, bundling issues, performance issues. So how it solve the single point of failures? Let's say the product is failed due to the product module code issues or maybe some other issues. Let's say product database is thrown some fatal error. That's okay. What will happen? Only the product is not able to access. This application is not able to access. But this category, brand, customer orders are still they are able to access. So earlier, the customer accessed the application like this. So this is the URL, http:// maybe vshopify app.in/ let's say app. So this is what the earlier application URL. Now the application URL will be here. It will be like brands-service, brands-service, right? Maybe it is like category-service, product-service. That means each and every service is now independently deployable. So each and every service now we can access on its network. Let's say category service, and maybe we will have now the product service. Now here is the product service, and here is the customer service. Here is the customer service. Here is the customer service. And here is the order service. Order service. Right? Now, each and every application and each and every module now acting as a tiny application. And as it is acting as a tiny application, this application have its own server, own build tool, our own infrastructure basically, and own database. So it is now independently executable application, independently deployable application. So this is now called as the microservices. Okay, now you can ask your questions if you have any on this microservices architecture. Now you can unmute yourself and ask your questions.
Yes, hi. Am I audible?
Yes, you are audible now.
So here I have two questions to ask.
Yes.
So each service will have their own domain or subdomain will be different. So it can work with single domain.
Yeah. So what we will do usually in this microservices architecture is each and every application will have its own authentication mechanism, meaning the security, but that security is not form login because these applications are not web pages. Rather, these applications will serve the data. That means the JSON data or maybe the XML data, whatever it is. These microservices will now serve the data, but not the pages. So the pages will come from the single SPS, single page applications like React or Angular. So React or Angular applications we will have here. These React or Angular applications will use these services to display these services related, pages. So these are all maybe React, maybe Angular we can use here. So whatever the data that is required to this React or Angular application, that data this React or Angular will get by calling these microservices URLs. So microservices will give the data. They'll expose the data rather than the view page. So to render the
Narsi,
data,
one question.
Yeah.
Then this front-end application, can't they be deployed as microservice?
yeah, front-end application is not the microservice, because front-end application is what? It is the consuming point. Meaning this consuming point will consume all the microservices. So front-end application definitely not the microservice. It is what, consumer. It is one application. So we can't say it as a microservice. There is
But
no
they
meaning.
will also be deployed into the Kubernetes, right?
Correct. These will be deployed into the Kubernetes. These URLs will be generated from the Kubernetes, and this also will be there in the Kubernetes. Yes, all these things will be in Kubernetes.
Okay.
Yeah.
And
First question.
One more question, sir, please.
Yeah.
What if our client will not allow to create so many databases?
Okay. So actually, here the problem is the licenses.
Yes.
Let's say if the single databases we want to purchase with the more, maybe the cost is more, let us say. Of course, the huge database may be with the 5 GB, but these databases with the 500 MB is good enough. But if that is the concern raised by the customer, for example, we may also use the shared databases. But if we use the shared databases, again, the single point of failures will be there. So we are going to this microservices architecture to solve one purpose. That purpose is what? Avoiding the single point of failures and avoiding the, let's say, the cascading relations to improve the performance. So these are all the benefits that we will get with this microservices architecture. So if we use the shared database, then it will be again the same problem we may face, that is single point of failures. So definitely customers or clients should accept this fact. So that is what the architect should have to be convinced. So cost wise, maybe the database, this huge database may require the 50 GB, but this may require just 2 GB. 2 GB, 2 GB, 2 GB. Let's say we have the 10 microservices, 20 to 30 GB is good enough rather than keeping the 50 GB database.
What challenge I face recently when I'm going to convert my existing product, which has about 36 modules. If I am categorizing each module as a web service, then I need to create 36 instances of database.
Correct.
So what I was saying, can I decrease it? Is there some solution that I can go for little databases instead of making so many instances?
First, what we need to do is, we need to implement it as a strangler pattern. There is a way actually. Strangler pattern. Strangler pattern meaning, first convert the microservices and use only single DB.
Okay.
And identify in the single DB if any of the services are using the common tables. Let's say users and customers. I'm just giving an example. Users and customers are using some common tables. Of course, they are interrelated. So whatever the commonalities, you keep it as 1 DB. And whatever the mostly affected module by the customer traffic, keep it as a separate DB. So likewise, we can cut down, if that is the concern, we can cut down. But most commonly traffic facing applications should have their own databases. And what are the applications which don't have that much of traffic? Maybe we can combine them using a shared database.
That's
Got
right.
it?
Yes. One more thing. That's last, please. excuse.
Yeah, no problem.
So I am working with 32 projects, running projects. So some of the projects are, using same tables like for authentication and authorization. So can we create a single service for authentication and authorization, and can we reuse for all of the application?
Obviously, that is what the microservices architecture is. You can see here. Yeah, these are all the microservices. Now, all these microservices are using a single IAM server, authentication and then identity management server, authentication and then access management server. So what will happen now? There will be a user management server, which will performs the login, generates the token from this identity server, keeps the token in the cache. Now the microservices, these will have been, constructed with the Spring security, where the filters will deny if the token is not coming in the request header. And that token, when it comes to this category service, let's say in the request header, then this category service will fetch the token from the cache, and then whatever the token that is getting in the request, both will be compared in terms of the lifespan wise and the token validity wise. If the token is valid, then only the response will get from this category service. So here authentication and authorization point is only one point, but it is reusing the token in every microservice for the authenticity and then authorization. Got it?
Okay. I'm done.
Yeah, thanks.
Narsi, is Ansible is replaced by Terraform totally?
Okay. Terraform is for infrastructure, that is called as IAC, infrastructure as code, and Terraform is used for the infrastructure management. Let's say we want to install this Kubernetes. We want to first set up this Kubernetes. For that, we need one master machine, let's say 3 worker machines. That master machine, worker machine will be created by the Terraform. Now, inside that master machine, we want to run a script. So that will be done by this Ansible. So Ansible will do the configuration management and Terraform will do the infrastructure management. So we can't replace the Ansible with the Terraform or Terraform with the Ansible. But Ansible will also do the Terraform job. That means Ansible not only do the configuration management, Ansible will also do the infrastructure management. But why we are going for the Terraform? Terraform will have the cloud agnostic behavior. That means once you write the scripts, Terraform scripts to create the virtual machines or create the infrastructure, just change the provider from AWS to Azure, Azure to GCP. That's it. It will target to the provider. Such a possibility not there in Ansible. So basically, Terraform will be used for the cloud agnostic infrastructure management or cloud native infrastructure management, whereas Ansible will be used for the mostly used for the configuration management. Got it?
Yeah.
Am I answered?
Yes.
Okay.
Sir, what is the use of sorry, sir, Apache Kafka and RabbitMQ in this architecture?
Okay, so these are event-driven mechanism. For example, you can see the product is using this category. Okay, let's say category data. For example, every product may be belonging to one or more categories. Let's say product is let's say LCD or LED TV, whatever it is, just a mobile. So that is belongs to, so let's say Samsung mobile. That is belong to a category called mobiles and whatever it is, other mobiles category. So category is the mobiles and then the product is the Samsung. So likewise, Samsung, Nokia, whatever, there may be n number of products under a category. Now, when the category get updated, let's say by chance category get updated. Now the category details will also be at the product service. Those are also need to get updated. The category details at the product, because every product is belonging to one or more categories, obviously. So product service will have the category details as well. So when the product is updated, when the category is updated, the product's data also should be updated. Product categories, what I mean to say is, I can showcase you let me just go here and then showcase you. So category service contains the categories, and then the brand service or the product service will use those categories, and then the categories will be also fetched from the category service onto the brands and then the product service. I can showcase, just give me a moment. It is now opening. This is the cloud monk browse collections. Just in a moment, let me showcase. This is the brands. Now it is fetching the documents. Yes, you can see now. Flipkart is one brand which contains these categories. So men's and kids category, which contains the 102 as a parent category. So go to this category, parent category meaning clothes and others. So now let's say when the category is updated, then this brands also need to get updated. So when the category get updated, then the brands or products and then orders, wherever the category is referring, that also need to update. So for that reason, we required a event triggering mechanism. Let's say category when updated, it will trigger an event to the RabbitMQ or Kafka. So when the RabbitMQ is now inserted with the category updated data, then the product service will be run with the RabbitMQ listener. So this listener will receive the latest data from the RabbitMQ about this category service and then update the product database. Got it?
Yeah, so in that case, the ELK will also get the data from RabbitMQ queues?
No. ELK is for the data. ELK is for the data. The logs actually. So ELK, of course, ELK also will get sometimes the data from this RabbitMQs and all, but mostly this ELK will get the data from the parts itself, meaning the cluster itself. So you can see this ELK will get the data directly from this Kubernetes parts. Okay. Got it?
Yeah. Okay. Thank you.
Narsi.
Any more questions?
So,
Yeah.
Yeah, where we can see only on-premises Kubernetes clusters or AWS or some kind of EKS clusters also we are going to be discussing this course.
Yes, EKS cluster also we'll discuss. Correct. EKS yesterday, if you can see the course content. Yes. Yeah, so we will first set up the on-premise cluster using Kubedium. Then we'll go for the cloud provider clusters like EKS, if possible GCP. Mostly I will go with the EKS only, not with the GCP. But if possible, I'll also showcase the GCP as well.
And one more thing is that can we see this pipeline also? We can implement this pipeline.
That is the whole and sole purpose. That is the whole and sole purpose of this Kubernetes with microservices deployment intention. So today we discussed about only monolithic application deployment, right? So tomorrow we'll discuss about how the pipeline, when there will be microservices. So let us discuss tomorrow, and then day after tomorrow onwards, let us start, setting up this Kubernetes installation and all.
Okay.
Right?
Okay. So what will be the duration of this course?
Duration will be 3 to 4 weeks. When I say 3 to 4 weeks, including the longer session on Saturdays and Sundays sometimes. So please expect a longer sessions on the every Saturday and Sunday, based on the need, based on the the pitch, how we are covering the syllabus. So based on the need, we will go for the Sunday classes, but every Saturday we'll have a longer session. By considering these longer sessions and all on Saturday, it will be 3 to 4 weeks. 3 to 4 weeks.
Okay.
So please upload the document in DevOps Classroom and the
Yes,
document.
I'll upload all these documents. I'll upload.
Thank you, sir.
Okay. Any more questions?
Sir, this regarding Jenkins, I would like to understand, once the code is committed, the Jenkins will be automatically called, or Jenkins is going to pull the code from the GitHub?
Yes. So your question is correct. How the Jenkins will know that the developer pushed the data or the PR pull request merged into this GitHub? How the Jenkins will know, correct? Yes. Yeah. Jenkins will have the hooks. We will configure the hook at the Jenkins side with the, This GitHub will have the hooks. Not only GitHub, you can take any SCM, source code management repositories. They will have the mechanism of hooks. Those hooks will be configured with the Jenkins URL. So when the developer will push the code, then this GitHub will trigger that hook with the commit details, commit ID details to the Jenkins. Now Jenkins will do what? Get a notification from the GitHub, right? As soon as when the Jenkins will get a notification from the GitHub about the latest source code commit with the commit ID, then Jenkins will go to GitHub and then pull the latest source code. Got it? But here the GitHub need to inform to Jenkins that there is a latest source code has been pushed. So for that, we will configure the hooks at the GitHub side.
Let's
Got
say,
it?
yeah, got it, sir. I have another doubt in this same scenario.
Hmm.
Let's say we are working on 10 members are working in same project, and
Correct.
10 people committed the source, committed their code.
Correct.
10 request means the code is committed to 10 people committed, 10 request, 10 files committed to the GitHub.
Correct. Let's say,
10 times it will poll and it will run and it will do this process.
No, that is not the process. In real time, what will the code never directly come to this. Code never come to this GitHub. Rather, code will go to the respective branches. Let's say developer 1 is working on one feature. So he will create one feature branch. So let's say this is the developer 1 feature branch. Let's say he is working on login. And then this is the another developer working on registration. This is another developer working on dashboard. This is another developer who is working on some other functionality. So now the developers first, when the ticket is assigned, the developers will first create their respective branches. That's a point number 1. And the developers will do the coding and then pushing the code, committing that code into their respective branches. So let's say this guy committed this code here, and then there is one more developer committed the code to this branch, and there is one more developer. Likewise, all the developers will commit the code to their branches, and then the developers will test the code in their local. Okay, once they tested, then they will raise the merge. They will raise the PR. We call it as pull request. So they will raise the PR into this common branch. There will be a release branch, let's say. So that release branch, they will raise the pull request. So from this branch, the pull request come to here, and from here, the pull request will come here. So all these pull requests will come here. Now, once this pull request is approved, then the code will be merged with the release branch. When all the code is coming to the release branch, then the build trigger will be happened. Got it?
Thank you, sir. Understand.
Yeah. Any more questions, folks?
Sir, today is my first session. So may I know what are all the things are we going to discuss?
Yeah, Lokesh, don't mind. Probably you will get the yesterday's video today. Just go through it. But just to let you know, yesterday we discussed about the Kubernetes content, what we gonna discuss during our Kubernetes sessions in this 3 to 4 weeks. So Kubernetes content we discussed, and that content is already there in our DurgaSoft online website. So content we discussed, tools we discussed, like Lens ID, Launcher. Of course, the recorded video also you will get today. So we discussed yesterday the just course content and then the tools. The main concept we discussed today only, that is the microservices architecture, monolithic architecture, how we can deploy, how the pipeline, right? So these are all what the main concept we discussed today. Yesterday, just course glance I have given.
Okay. So in microservices, are we going to discuss these gateways and everything?
Yes, obviously. When it is a microservice, there will be an ecosystem. When there will be an ecosystem that contains the gateway, that contains the service discovery, that contains the security, that contains the resilience 4J, that contains the event triggering, contains the observability, logging, everything. This is called as an ecosystem. This entire ecosystem will be deployed to manage these microservices.
Okay, I think like we are going to discuss everything on it, right, sir?
Correct.
Yeah, okay. Thank you, sir.
Any more questions?
Sir, what we have discussed until in the DevOps classes as similar to the monolithic applications?
Monolithic application deployment is, yes, what we discussed so far in DevOps
Yes.
is monolithic application deployment. Correct. Perfect. That is the monolithic. Now going to discuss about the microservices deployment going forward.
Okay.
Yeah.
Sir, another thing, there is an error in form file also reported in Telegram.
Yesterday I said I resolved it. I will zip it and then upload today. I resolved it.
Okay.
You
Okay.
also, you guys also can, just check it. What we need to do, there is this
Parent.
parent artifact. Just
Yes.
comment this parent artifact. That is good enough. Okay,
Narsi,
just
is there any
comment it.
going on from by you?
Sorry, your question is, meaning your voice is not audible properly. Can you please repeat that?
Is there any DevOps batch? Total DevOps batch is going on? I mean,
Yes,
from you?
yes, correct. So total DevOps batch is now going on, but we are now at the end. So the two topics were left, meaning two tools were left. One is the Kubernetes, second one is the pipeline as code. So as part of this Kubernetes, now started the separate batch for this Kubernetes one. So we already completed this entire pipeline. So this is till here we completed.
When is there any new batch it will start for you?
Yeah, going forward. Maybe once after this is done after March 15th, then we'll start a new batch.
Okay, thank you.
Sir,
Sir,
is
what
this course for DevOps or is this course for microservices, Kubernetes?
This is Kubernetes with microservices deployment course. And of course, DevOps guys also need to know about this microservices deployment. Usually what will happen in real time? The developers will develop the microservices, but who will set up this pipeline? DevOps only, right? So the course is Kubernetes deployment with microservices for everyone. That is not only for DevOps, not only for Java, not only for .NET, not only for Python, for everyone this is. Because cloud native, the concept of cloud native is the primary motto of this Kubernetes. So no matter what is the cloud it is, no matter what is the language it is, because we are deploying what the microservices. Microservices are the technology agnostic. So what I mean to say is Kubernetes with microservices deployment is a course for all, not DevOps, not Java. It is for all.
What is the course content, sir? What and all it covers?
Yeah, what and all it covers is what we discussed yesterday. That means, first of all, this Kubernetes course content, just go through it in our website. And in this Kubernetes, once these Kubernetes course content and Kubernetes concepts were covered, then we will set up this pipeline for the microservices architecture. So today we have seen this microservices architecture, right? And tomorrow we'll discuss about the pipeline blueprint, like how the pipeline will be for these microservices and how we can manage them and how we can deploy them. So tomorrow we'll discuss about the blueprint of it. So the microservices deployment in the Kubernetes cluster is what we're going to cover throughout this course. So if you attend tomorrow, probably you will get complete picture, like, how the microservices will get deployed into the Kubernetes via the Jenkins pipeline.
So whatever we have discussed today, we are going to implement that, or only
obviously.
we will. So all the like Docker, pulling image, and ELK, everything we will be set up, all the pipelines.
Correct. Everything will be set up in pipeline. But Docker, meaning I don't tell this Docker classes again because this is the Kubernetes one. So this pipeline, like Jenkins master, slave, and then the SonarQube, Artifactory, Ansible, Docker. This pipeline is already there. This pipeline is already there. So I'll explain how this pipeline was and how we created and all. I'll explain this pipeline. Then we're going to set up this Kubernetes cluster, and then we'll integrate this Kubernetes cluster with the pipeline. So this part is what we're going to do. So this pipeline is already there. So I'll explain how this pipeline has been set up.
So for setup, apart from the Kubernetes, all these pipelines, we need to do our extra effort, or we will going to provide these things.
Okay, basically you guys have to set up all these things from the very scratch. So for that, I'll provide the step-by-step execution documents. Follow the document and then execute it. That's it. It will work.
Yeah, because if we'll jump directly on the Kubernetes, we will not understand what will be the story behind that. So maybe we will be only in the dumping area. So
correct. Understood. Definitely these points I'll explain, and if possible, let us set up also. Setup will take at least 3 to 4 weeks of time. This entire setup. If possible, let us also do the setup. If possible, I'm not guarantee, but definitely when we set up this Kubernetes master, when we install and then done it's a setup, and when we integrate it with this pipeline, then already existed pipeline, definitely I'll explain how these are integrated, how the call is going, all this I'll explain. Okay, because the time is 3 to 4 weeks. Again, installation, deployment of all these tools. So maybe take 1 week of time. So this pipeline installation steps, scripts, documents, all I will provide, and also the pipeline, how it has been set up, these tools and all I'll explain, so that the Docker will be integrated with this one. I think you can understand now that when I discuss this pipeline and all. Okay, got it right? Any questions for me? Okay, so that's all from my side, folks. Thanks a lot for your participation and your interest. And this Saturday, we're going to close these demo sessions. If interested, work up with the backend team about the registration and all. Thanks a lot. Any more questions?
Will we be having any class on this Saturday?
Yes. This Saturday, we'll have a Kubernetes installation and then setup class. It's a longer session, which gonna start from 7:15 a.m. to maybe 9:30 or maybe 10.
Okay.
So complete this Kubernetes setup this Saturday. Okay.
We are good. Thank you.
Yeah. Okay, folks. Thanks a lot. I'm stopping my screen share. Yes, tomorrow we have a session. Okay. So thanks a lot. Stopping my screen share. And then see you tomorrow at the same time. Thanks a lot.